No, the red button is on. Yes, you're recording now.
Oh, I can see the red button. Well, yeah, I see the red button there. Don't matter. All right. So last week we started talking about standard deviation. I introduced you. We actually did stem and leaf plots, and then we did shape, left skewed, right skewed, and symmetrical shapes, symmetric shapes. Today we're going to talk about. I'm going to go back to standard deviation real quick because I did it. I did it through Excel to show you how to get it like that by hand and everything. Because I think on your tests you can't use a calculator, or you can't use Excel. You can use a handheld calculator. So I'm going to cover that one more time. I'm going to do the exact same problem, except I'm going to do it by hand. And I'm actually going to teach you the difference between, there's two types of standard deviations. And we'll start there first tonight, all right? So let me bring that up. All right. So again, we started talking about the variance in the standard deviation last time. And remember, we went by the definition of standard deviation. And the definition was just this: the standard deviation is the average deviation from the mean. And we defined that. And once we had that defined, we did everything from there. And there's two types of standard deviations, all right? So there's what's called the, first off, there's what we have is called the population. And population means you know everything. And for that, we call it the standard deviation. Is this thing that we call the Greek letter sigma. That is the Greek letter sigma, lowercase sigma. So when I talk about a population standard deviation, I'm talking about sigma. That assumes you know everything. The population variance, which is, and the variance, remember we tried to find the average of the deviations by adding them, and we got that sum of 0. So the variance is the squared deviations, the average of the squared deviations from the mean. And the variance is what we call sigma squared. So these two are related by each other. One is sigma and one is sigma squared. If I want to get from sigma, the standard deviation, to the variance, I just square sigma. If I want to get from the variance back to the standard deviation, I take the square root of sigma squared. All right. And the problem with the population, though, the population is what we call a biased estimator. It's biased. This one is biased. So we always look at the unbiased estimator when we talk about this. And the unbiased estimator is going to be what we call, it comes from the sample values. So it comes from the sample. And this is what we call unbiased. It's called unbiased. And we call the standard deviation for the sample, we call it S of X. And the variance for the sample is called S squared of X. And again, the only real big difference is that this one divides by a bigger number. Population values divide by a bigger number when you find the average. This one divides by one less that number. So here's the example we looked at last time, right? And there's two types of standard deviations again. There's sigma, which is the population value. So if I want to find sigma, call it sigma x. Sigma x is equal to the square root of the big Greek letter sigma, which stands for the sum of x minus, we call this mu. And you may not know what mu is because I don't think I ever told you what mu is, but mu is equal to the population mean. This is what we call our population mean. So if we know every value in the population, for instance, let's say I take all the test scores that I have between these two classes. I have 80 people in these two classes, right? I would know every person's score. I could find the average, the population mean. Does everybody understand that? Of all 80 people. That's the population mean. And so when we talk about a population value, this is a population. Generally speaking, these population values have Greek letters. So when you start to see Greek letters popping up like this as values, that means they're population things. And all this is saying is x minus mu. Well, x, these are your x's right here. These are your x's, and you're subtracting them from the mean. And remember, when we calculate anything minus the mean, or in particular, x minus mu, this is called a deviation. It's called a deviation. And a deviation just tells you how far away from the mean you are. So for instance, we got our mean, assuming that this was a population. If this was the population, then our mean mu is equal to 75. And we found that again by adding up all these values and dividing by the total. That was equal to 75. So from there, I can go and find the deviations. I can find these deviations, x minus mu for each value. And we did that like this. I'll write it out. I'll make a table real quick. So here are your x's. You have 57, 64, 72, 82, 84, and 91. And then we calculated the x minus mu part, the deviations. So if I want to find the deviations of each one of these things, if I want to find my deviations, remember some are positive and some are negative. The ones that are negative will always be below the mean. So if our mean is, basically you're going to do x minus 75. If a number is less than 75, it'll be negative. If it's more than 75, it'll be positive, right? So when I do this, I get 57 minus 75. That's equal to, I think we said negative 18 last time. 64 minus 75, that was equal to a negative 11. 72 minus 75, a negative 3. And then the next ones are all positive because they're all bigger than 75. So 82 minus 75 was 7. 84 minus 75 was 9. And 91 minus 75 was 16. And remember, we tried to total this because we wanted to find, by definition, it's the average deviation from the mean, right? Well, we have the deviations. We have the deviation from the mean. And when we tried to total this value, when you add them all up, we got 0. And it's always equal to 0. So to fix that, we took these deviations, x minus mu, and we squared them. And then made them all positive. So if I start squaring values, (18) squared is 324. Negative 11 squared, 121. 3 squared, 9. 7 squared, 49. 9 squared is 81. 16 squared, 256. And now, because they're all positive, we can just add them all up. Anybody remember what we got when we did that? I feel like it was like 480 or something. 840. So we get 840 when we do that.
I have a question.
Listening.
How do you get mu? How do you get the
Average?
The mean?
We just found the average of these numbers right here. How do I get the average of those numbers?
Okay, you just add them all up and divide them by the number of
6 plus 57 plus 64 plus 72 plus 82 plus 84 plus 91 is this divided by 6, 75. Got that?
Yeah, thank you.
Cool. Now, once we have this, then next step, once we got that, next step is to we're working on the variance, which is the average square deviation. So to find the average, we decided that we had to divide that 840 by what? Divide 840 by the total, right? 6. So what we found when we do that, that's called sigma squared. So your sigma squared x is equal to 840 divided by 6. And that's equal to 140. And then so if that's 140, this is what we call right here, this is the variance. That's the variance, right? If I want the standard deviation, this is called sigma x. And all we do is take the square root of the variance, which is 140 here. Square root of 140 is 11.832. 11.832. So that's how we did it last time. We did that for the population. And so both these values right here, since they're Greek letters, for one, that tells me they're population values. And so this is the population values. And they are biased. All right. So generally speaking, here's what happens then. Because these are biased, and they're biased because I'm looking at a sample, not a population. I only have 5 values. So that's not the entire population. That's only 5 values out of the entire population. So what ends up happening is this standard deviation, 11.832. By the way, let's talk about what that 11.832 means first. That 11.832 is the average deviation from the mean. All right. So that means on average, what is our mean value? So what is our mean value to begin with? Well, our mean value is 75, right? So what this is saying that on average, on average, the values are going to deviate away from 75 by about 11.832 score points or test points, whatever we're calling that, all right? Now, this is too precise though. That's too precise because we've taken a sample. And a sample assumes that you're grabbing parts and missing others. So we need more error. So to make this have more error and to have it make it be what we call an unbiased estimator, we take the sample like this. The sample works the exact same way. We call it S squared of X. And the only difference here is we're gonna take that 840 that we got, and we're gonna divide it by 1 less. You divide it by 1 less than the sample size. So if our sample size was 6, we're gonna divide by 5. And so when I divide 840 by 5, this is called the sample variance. This is the sample variance. All right. And this is going to be something that we're going to use. And I think on your homework, most of the problems want you to find the variant, the sample. They want the sample values. And if this is the sample variance, then to get to the sample standard deviation, which we call S of X, it's equal to the square root of just 168. So the square root of 168 is equal to 12.961. So that's 12.961. And if you notice the two values now, if you compare values against each other, look how much, this one's slightly bigger than that one now. That's what you want. You want the bigger value. So when you're talking about sample, your sample value should always be bigger than the population values. And generally speaking, we're interested in the sample values. But this process right here, this table that I made, is how you're going to do all your problems. Find your x, take your x's, find their mean. Once you have the mean, start subtracting each x from the mean, get deviations. Once you have the deviations, you square them and add them up. Square your deviations, add them up, I get 840. For a sample, you do 840 divided by, to get that average value, you always do one less than the actual sample size. That's for a sample. And most of your problems will be samples. But if they do actually for a population, only thing different is you don't subtract it by 1. But once you know the variance, you can go to the standard deviation by taking the square root. That's the process.
Professor,
Yes, ma'am. Yes, ma'am.
can you go through that again? Like, just say exactly what you said again.
Okay. You ready?
Yes.
Okay. So look, first thing I'm going to do is I'm going to take these x values. Right? I'm going to find their mean. My mean is 75. And I got that by adding up all these x values and dividing by the total. When we add up all these x values, we got, I think it was 450. We divided by 6. 1 more second. Yeah, it was 450 right here, and divided by 6. And we got 75 as the mean. That's the first part. You have to have a mean first. Once you have a mean, you take each one of these x values and subtract it from that mean. I'm going to do 57 minus 75. I get negative 18. If the x is slower than the mean, the x is smaller than the mean, you should get a negative number, which these 3 x values are all smaller than 75. That's why they got negative numbers. If x is bigger than the mean, you should get a positive number. These 3 x values are all bigger. That's why you got a positive number, right? Now, after you do that, the next step, we tried to find the average of these deviations before. We kept getting 0. So to fix that, we take all of these deviations and we square them. So this is just negative 18 squared, positive 324. Negative 11 squared, 121. Negative 3 squared, 9. So I'm taking all of these deviations I found, I square them, and I add that number up and I get 840. And then from there, depending on what you're finding, if you're finding the population, you take 840 and divide it by the total number you have, which is 6. Most of the time, though, you're finding the sample. So you're going to take 840 and divide it by 1 less than whatever your sample size is. So my sample size here is 6. I'm going to divide it by 1 less, which is 5. This squared term is the variance. And we can get the standard deviation by taking the square root of either one of those.
Thank you. And on the exams and homework, is it always going to say like find the variance or find like the sample?
It'll tell you to find, it'll tell you, it may not say explicitly find the sample, but it says a sample, it may say something like a sample of, oh, look right here on this particular problem. It's an example. The following scores are a, look what they are. They're a what?
Sample.
So that tells me I need to find a sample for this entire thing. You got that?
Yes. Thank you.
Mm-hmm. Everybody else okay? Yes. So the next thing we're going to talk about is what we call quartiles. We'll talk about quartiles. And quartiles split an ordered data set into 4 equal parts. So ordered data sets, first off, are, that means they're written from smallest to greatest. That's what an ordered data set is. And it splits that smallest to greatest into 4 equal parts. So basically you get quarters, right? And they measure the position. They measure position and are resistant to extreme outlier values. So what position means is this then. When I tell you that a position is something, you're looking at 25% of the data lies within each quartile. And we make this graph right here known as a box and whisker. And in this box and whisker, here's how this works. The lowest observation, this lowest observation right here, is called the minimum. called the min. And from the min to what we call our lower quartile, or Q1, from the min to Q1 is 25% of the data. And so what that means is if it's 25% of the data here, right? In the next quartile from Q1 to the median is also 25% of the data. And then in the next quartile from the median to Q3, which was called the upper quartile, Q3 is called the upper quartile, it's also 25% of the data. And then from the Q3 to the highest observation is called the max. Right? And the max from Q3 to the max is also 25% of the data. Hence why it's called quartiles. So when you do things like with quartiles, here's what you're asking yourself. I could ask you questions like true or false? True or false? There are more values from the median to Q3. There are more values from the median to Q3 than there are from the minimum value to Q1. True or false?
False.
Why? Good. It's false. Why?
These are the same.
It's the exact same amount of values, right?
Hmm.
They're the exact same amount of values. Everybody understand that?
Yes.
There's 25% within each one of these. So you can't say there's more values. There's 25%. All right. Now, the other thing that we need to know about this is it's a measure of spread or how spread out the data is. So if I know the max and the min, for instance, the max and the min, I can always find the range. If I know the max and the min, I can always find the range. The range is one interpretation of spread, and it tells me how loosely spread out the data is. So remember, like for instance, when I gave you the rocket salaries the other day, yesterday on Tuesday, the range there was 49, was like 41 million for the max. The min was 2 million, so that's a 39 million spread. That is a huge number, and it doesn't tell us a whole lot about the data other than it's very spread out, right? So what this does now is this gives us more positions in the data. It tells us more positions in our data. In particular, the one thing that we're really interested in is the box that is made from Q1 to Q3. We're really interested in this box made from Q1 to Q3. And this box is what we call our interquartile range. It's called the interquartile range, or the IQR. And it gives us the middle 50% of the data. It tells us how spread out the middle 50% is. So if your IQR is fairly small, it means that the middle 50% is very close together. And when you start comparing your IQR to your range, and if your IQR is small and your range is very far, that means you have very extreme values outside of the IQR, or very extreme values in your data set. If your IQR is small and your range is small, that means that your data is very close together. All right. If your IQR is big and your range is small, that means that you have a lot of values on your extremes. If your IQR is big and if your IQR is big and your range is small, that means that you have a lot of value. I just said that. If your IQR is big and your range is big, that means your data is very spread out too. So that's what we're looking at. The IQR tells you how spread out the data is. It's a nice measure because it gives you the middle 50%. The closer it is together, the tighter it is together, the more compact your data is. The closer your data is to a value. All right. And this is what we show in a box plot. And this box plot gives us what's known as the 5-number summary. So the 5-number summary is made up of the min, Q1, median, Q3, and the max in that order. That's because we call it the 5-number summary. And they give you positions of the data. They give you the positions of the data. And again, like we were talking about the mean and the median being resistant measures, being resistant versus non-resistant. Remember, resistant measure means that outliers do not affect it. The median is a resistant measure. The outlier does not affect it. In this case, the 5-number summary is pretty much resistant because you have your quartiles. Your quartiles are resistant measures. Outliers do not affect them. They want to sit in positions. Q1, the median, Q3 are all resistant measures. On the other hand, the standard deviation is non-resistant. Standard deviation is non-resistant because very big values affect the standard deviation. But that's, again, think about how you find your standard deviation. You go through that process of taking every value. You have a mean that you're taking values from. So that's going to be affected by a big value to begin with. And then you're adding up other values. So every value is input into the standard deviation. So the standard deviation, just like the mean, they're both non-resistant measures. They're both heavily affected by outliers. Write that down somewhere. That's an important thing. Standard deviation and mean, non-resistant, they're both affected by outliers. Quartiles and the median, they're resistant measures. That means extreme values do not affect them very much. And again, remember when we talk about each one, the mean and the median are what we call center measures. They're what we call center measures. They tell you typical values. You talk about the mean of the data is symmetric. You talk about the median if it's skewed. The standard deviation and your quartiles, standard deviation and quartiles, are what we call measures of position or measures of variation. They're called measures of variation. And you talk about the standard deviation if the data is symmetric. If the data is symmetric, it's okay to talk about standard deviation. You want to talk about it because it takes into account every value. If the data is skewed, though, you want to talk about your quartiles. You got that? Yes.
Yes.
Thank you. So let's go ahead and find some quartiles, please. We'll find the quartiles. It says find the standard deviation. We're not going to do that. We're just going to find quartiles real quick. Here's how we find quartiles by hand. First step, a quartile divides an ordered data set into 4 equal parts, right? So data set, is it ordered? Yes or no? Is it ordered?
Yes.
It looks ordered. Thank you so much. I appreciate
It
it.
is.
Thank you.
Yes.
Thank you. So it's an ordered data set, right?
Mhm.
Because it's ordered already, here's what we need to do. Here's how you find the actual quartiles. The first thing we're going to do, we're actually going to find the 5-number summary here. All right? Because the 5-number summary gives me the quartiles. So my 5-number summary is made up of the minimum value. What's the min value here? What's your min value?
43.
It's 40.
43.
Good, it's 43. It's made up of the max value,
96.
96. And now we need to go find Q1, median, and Q3. We need to find the values, all right? Out of those 3 values, which ones do we know how to find already? Which one do I know how to find already?
The median.
Median. I
Median.
gotta find the median, especially of remember we talked about this last time, to find the median of this is a 1, 2, 3, 4, 5, 6, the median of 18. So you're in here, your sample size n is equal to 18. That's an even number. So to find the median of an even number, what do? We take 18, cut it in half. 18 divided by 2 is 9. So the first median occurs at 9. 1, 2, 3, 4, 5, 6, 7, 8. Here's your first median. The 9th value. The other median occurs right behind it at 80. So to find the median, all I do is I do 77 plus 80 and divided by 2. That's equal to 78.5. That's equal to 78.5. So there goes the median. So basically the median is cutting this thing right in half right here. You got that? On this side should be the same amount of numbers, which is there's 9 on this side of the median. There's also 9 on this side of the median. Everybody got that? Now, the next step to find Q1, you just look at the lower half of the data. Q1 is the 25th percentile, right? The 25 or the 20, it cuts the data in 25%, but 25 is half of the median. So all it is the median of the lower half. It's the median of the lower half. And on this side, we know we have 9 values. And so if I divide 9 by 2, I get 4.5, which is an odd number. So I'm going to round this up to 5. So the median for the lower half occurs at the 5th position. 1, 2, 3, 4, 5. Here's the median for the lower half. That median, this right here, is Q1. That is Q1. It's just the median of the lower half of data. So that median is at 62. To get the other median, we do the exact same thing. If there's 9 on this side, there should also be 9 on this side, right? So we need to count to the 5th position. 1, 2, 3, 4, 5. Here is Q3. And that's at 90. Now, here's what I know. I know the minimum value is 43. Q1 is 62. The median is at 78.5. Q3 is at 90. And the max is at 96. I can also find other things from this. For instance, I can find the range, right? The range of the data set is equal to 96 minus 43, which is 53. And I can find the IQR. The IQR is 90 minus 62, which is equal to 28. All right, that's 28. So these are the values of, these are the measures of variation now. So these are the measures of variation. Here are your quartiles in the middle right here. And then max value, range, IQR. And from this, we can produce a graph. This is the last graph you're gonna need for your project. From this, we can produce the box and whisker plot. And so a box and whisker is just this. Make a horizontal axis. I'm gonna label this horizontal axis with the 5-number summary. Label the horizontal axis with the 5-number summary. And your 5 numbers are the minimum value, is at 62. Q1, I'm sorry, minimum value is at 43. Q1 is at 62. The median's at 78.5. Q3 is at 90. And the max is at 96. And here's how this works. The box is made, the box is the IQR, and the IQR is from Q1 to Q3. So I make the box from here to here. Inside the box is the median. Inside the box is the median. The median does not have to be in the middle, exact middle of the box, by the way. It can move left or right, depending on how spread out the data is inside the IQR. But this is the median. Then we draw whiskers to the lowest value down here and the highest value up here. And this is our graph. This is the box and whisker plot for this. And when I look at this box and whisker plot, I can also tell the shape of the distribution. I can also tell the shape of the distribution. And remember, our shapes are symmetric, left skewed, right, and right skewed, right? So if we want to tell shape from a box plot, Here are your different shapes. In a symmetric box plot, that's what symmetric looks like. I'll come back to it in a second. In a left skew box plot, that's what left skew looks like. And in a right skew box plot, here's what a right skew box plot looks like. Without me telling you anything right now, what's the shape of our box plot right now?
Left skew,
Left skew. Why is it left skew?
because it's more, it's even there in the middle, but more, there's a difference with
Longer. The whisker is longer on what side, the left or the right?
the left side.
Left side. That's how you look at it. You look at your whiskers. If your whiskers longer on the left, it's left skewed, right? If your whiskers longer on the right, that means that it is right skewed. So here's what I really want to know then. Can you tell me what the mean of this distribution is? The mean of this distribution just from this box plot. Can you tell me the mean of the distribution just from the box plot? Like if we didn't have this right now, can you tell me the mean? If we didn't have any of this, can you tell me the mean of the box plot?
Where's the mean? I think the mean.
Can you tell me the mean?
I think so.
Can you tell me the mean?
Couldn't you just divide like
I
the
don't
5
numbers
numbers?
down here. I can't tell you the mean. I can't tell you the mean. I can only tell you the what. What is this?
Median.
That's the mean. I can tell you the median, but I can't tell you the mean. I can tell you though. Here's what I can tell you about the mean. I can't tell you what the exact mean is. I do know that the mean is what though, compared to the median. I can't tell you what the mean is. I can tell you that it compared to the median, the mean is what? Is it less than or greater than the median?
Less than?
It is less than. Because in a left skew distribution, here's what we have, by the way, in case you forgot this. In a left skew, in a symmetric distribution, the mean equals the median.
Oh,
In a left skew distribution, the mean is
Less.
less than the median. It's on the left-hand side. Remember, the skew is the mean.
oh
So
yeah.
in left skew, you're skewing the mean.
Is mean greater than.
Yeah, and the right, the mean is
Greater.
the median. Was this docket, was these scores inside the last one that I gave y'all? The last Excel document I gave y'all? I'm not sure if it was or not.
I find this process a lot easier.
Which process?
This one, what
Making
you
a box
just,
plot?
yes.
Yeah. Box plots are pretty simple when you do, especially if you're doing by hand.
Yes.
Problem is that y'all can't do everything by hand. Because we can't, if I could teach this class by hand, it'd be a lot quicker for me too. But because I got to do things in Excel, you know, it kind of like forces me to do other things with y'all. Like right now, we're about to go make a box plot in Excel.
Okay.
Let me get that data up. Let me find it from last time. Open recent. Yeah. Did I get that? I gave that one to y'all last time, right? Y'all need it again? That particular set? I need it again? Everybody got it? Okay. If y'all all got it, then let's go with this. Let me show y'all my screen real quick. All right. So here are those test scores again, and they're already lined up in order and everything for us, right? And I want to show you how to find the 5-number summary from this, because you can't just go out and find the 5-number summary like it is. We can use functions to do it. So we want to find the 5-number summary. Remember, it's made up of the minimum value, Q1, median, Q3, and the max. It's made up of those 5 numbers, right? And so to find this one, you can either look at the table, or if you didn't have it sorted, another way to find this one, you would just do equals. There's a min function here. There's the minimum function. Highlight your cell ranges like this, and it'll find the minimum for you. Same thing with the max. If you go to equals, type in max, highlight your cell ranges, it'll find the max for you, right? So there goes the min and the max. To find the median, we know we have that function already. That's equals the median function. Highlight your cell range, produces that. There's that one. And we wanted Q1. So to find the quartiles, there's a couple functions you can use. There's what's called the percentile function, the percentile function. So the quartile is just a percentile. You can use that function. And you may need to use that function one day if you're talking about different percentiles. But since we're talking about quartiles, quartiles has its own function. Start typing it in. There's 2 different quartile functions. There's quartile.exe and quartile.inc. You always want to pick the INC, the inclusive function. One is exclusive, one is inclusive. You want it to be inclusive. You're going to include the bound value below it. So to find Q1, highlight your data like this to find Q1. And because there are technically 3 quartiles, the first quartile, Q1, the second quartile, also known as the median, and the third quartile, Q3, you have to specify to Excel what quartile you want. We want and you see how it pops up like that? So we want the first quartile. And technically you can get your 5-number summary like this too, by the way. We want the first quartile, Q1. And that's equal to 62.5. Is that what we got? Wait, I might have told you the wrong function. I think I did tell you the wrong function. It should be EXC. EXC, my fault. Too few arguments, but I need to add the 1 in the back. No, it should be INC. I was right. I know what it's doing. And I'll tell y'all what it's doing too. I like this. Remember on ours, we got, what do we get for Q3? I mean for Q1. Q1, we got 62, right?
Yes.
This one's getting 62.5. And what it's doing, what Excel is doing is Excel is actually, when Excel sees an even data set like this, it treats everything, every median as it needs to be split. As it needs to be split. So if you look at Q3, Q3 will probably be off too. Quartile, EXC, not EXC, INC. INC. I'm doing the third quartile this time. And I get 88.5, yeah. And we got what for Q3? 90, yeah. So what Excel is trying to do is Excel wants to always treat everything like it's an even number and split it in half. And so for every one of these things that Excel is doing, and here's what I want you to understand. It's not necessarily wrong. It's not wrong. Because what you're really doing is you're just graphing the data. And when you graph the data, you're looking at the data, look at shape. So we got, for instance, we got 90 as our Q3. Excel is getting it as 88.5. Those aren't horribly off. And when you go to graph them, they'll pretty much look the same thing when you draw a graph of it. And since you're going to be doing most of it by hand on a test, I will want you to give me what we got on the paper. But like on your projects, I want you to use Excel to actually get that number. So whatever Excel gives you, use that number, but use the EXC function. Use the EXC function when you find the quartiles, all right? So this is the 5-number summary for these particular values. Once you have the 5-number summary, you can find other things like I want the range. If I wanted the range, I would just do the max minus the min. There's your range. If I want to find the IQR, that's equal to Q3 minus Q1. If I wanted the standard deviation, should be another function, another thing we can find, equals SD. And again, this is a sample. Because it's a sample, you're going to use the standard deviation S. You have two different ones, by the way. Standard deviation P, that stands for population. Standard deviation S stands for the sample. We're going to use S. And even on, I'm showing you all this because on your project, you got to find a lot of these things. On your project, you're going to use S. So when you do this, highlight your cells. Do this again. Standard deviation S. Highlight these cells. There's your standard deviation at 16.0486. We can find the mean. The mean is just the average function. So highlight that, use the average function. We get this value right here. And if you look here, what did we say about the mean earlier? Did we say it was less than or greater than the median? The distribution was which way again? It was skewed which way? Left or right? It was skewed to the left. Because it was skewed to the left, we said the mean right here.
It was
It's
less
less than
than.
the median. Yes, well, it's less than the median. Do y'all see that?
Yes.
So we knew that from just looking at the graph, by the way. Just looking at the graph, we could figure that out without finding any mean. So here are some of the values that we can find, all right? Now, we're going to make this into a box and whisker plot, a box and whisker plot. To make the box and whisker, you have to get creative. Technically, you don't. Technically, there is a box and whisker function that you can use. But I want you to actually try to make it by hand first. So I'm going to walk it through hand first. And then I'll show you the actual function too, the actual chart function they have for it. So in order to do the box and whisker though, you're literally going to make boxes. You're literally going to have to make boxes and use kind of like a hack to get a box and whisker. So in order to do that, here's what we do. These are our test scores. And for these test scores, we need to know the differences. The differences between each one of these different, each quartile, difference between each quartile. And we always start off with the minimum one as it is, so 43 is here. But then I want to find Q1, the median, Q3, and the max. So for this one, I want to find the difference between Q1 and the minimum. The difference between Q1 and the minimum. So all I do is take this, here and subtract it from this 43. I get that. And honestly, I probably should do it because I want to drag this formula down. Yeah, I don't want to do it like that. Let's drag the formula down. So I need to do it a different way. Instead of doing like that, let's do equals this minus this right here. There.
You can use the dollar sign to keep the 43 there.
Yeah, I know. But the thing is, I don't want to keep 43. I want to keep going from, because the next one will be this. I want to do this minus this right here. See what I'm doing? I'm just subtracting. So the next one will be Q3 minus the median. I'm subtracting by the quartiles. Equals Q3 minus this right here. And that's what the last one should be, 7.5. D7. Yeah, D7 minus D6. Yeah, that's what it should be, 7.5. So the first thing is to find these differences between the different things, all right, for the test scores. And I probably should have switched these columns around. Do it like that so you don't get confused. There. So there are your differences between the different scores, all right? And what you're going to do now to hack this is we're going to go make a stacked bar chart. A stacked bar chart. And I actually want to do a horizontal stack bar chart. So I actually want to do this one right here. This 2D horizontal stack bar chart. And right now, what it's doing is it's reading the wrong rows. It's reading the wrong rows for me. So I need to go ahead and fix that. I need to find my thing where I can switch it. I just want to switch the rows and the columns, but I don't see my thing. Format. Nope. Chart design. Oh, there it goes. I want to switch row and columns. So this is what I wanted to look like to start off with. Everybody got that? Everybody understand that? So I went to a stack bar.
Yes.
I highlighted these cells right here and went to a stack bar chart. Everybody understand that?
Yes.
All right. Now, what you need to do is then, what you're interested in is from here to here, from this part to this part is going to be the minimum value. All right. Up to this part is the minimum value. I don't need to see this though, because that's not what the bar chart, that's not what a box and whisker plot is made of. It's box and whisker, the inside is made from where? From Q1 to Q3, right? Everybody got that? Q1 to Q3. And so the way this works is this part right here has no effect on the graph at all, to be honest. So I don't even want to see that. So here's what I'm going to do. I'm going to format this and get rid of it. Because basically what that first part does, that first part pushes the graph, shifts the graph to where it's supposed to be. That's what it's doing. So I want to format this. I'm going to change this to up here where it says fill at. I don't want to see it, so I'm going to no fill. I'm going to get rid of that. All right. And we know our minimum value starts where at? Where's our minimum value start at? Anybody?
43.
43. So look where the minimum value is starting at now. Where's it starting at?
43.
43. So that's why I had to get rid of that first part, all right? Trying to make this big for y'all. Now, that means that this from here, from the orange, from the gray to the orange is Q1. Or from the gray to the orange is Q1. So that's going to make up the minimum of Q1. This gray part is from Q1 to the median. This yellow part is from the median to Q3. And this blue part is from Q3 to the max. So the box itself is from the gray to the yellow. So again, I'm going to do this to the orange. I'm going to make that go away. No fill. And I'm doing this through my chart design, by the way. Chart design. I'm going to make the blue go away with no fill as well. So when you look at this now, Where is Q1 starting at?
Around 62, 60.
62 and a half, right? Because it should be right here, by the way. Where is Q3 ending at?
88.
88.
88.5, which is about where it should be. Does everybody understand that?
Mhm.
Yeah, it's almost
So
at 9.
our box is already made for us. The last thing we need to do is do what? Extend our whiskers out, right?
Mhm.
So to extend the whiskers, here's what you do. The left whisker, click anywhere on the left-hand side of this gray box. And the part that you shaded that you did no fill to, you're gonna add a graph on top of that. We're gonna add a graph on top of that. All right. And in particular, we're gonna insert what we call, I couldn't find it on mine earlier. I had to go to insert up here to do it. You're gonna insert a chart. And you're going to insert, where is it at? No. I gotta find it again, you guys. 1 second. Oh, add chart element. You're gonna go to add chart element. It's under your chart design, by the way. It's under chart design. You're gonna add a chart element, and you wanna add these things we call error bars. You wanna add error bars. But you wanna add the one, you don't want any of these right here. You want the more error bars option. And when you go to more error bars option, look what it put up here. You see what it put up? We don't want that error bar to be way over here. We want it to stop right here, by the way. So here's what we do. Up here, you can readjust the stuff. You can readjust things. You can readjust the actual bars themselves. We want this left one to be our minus bar. It's our minus error bar. Right? And then we also want the link to be the custom bar. We want to customize that link. And we're going to specify how far we want that bar to be. All right? So we're going to specify the value. And we're dealing with what's called the negative error bar right now, the negative error bar, because we're on the left-hand side, the negative error bar. So I'm going to clear all this stuff out of here. I don't want that in there. And I'm going to set my negative error bar to wherever Q1 is. Set the negative error bar to wherever Q1 is. The difference in Q1. And when I come back here and go to OK, look what it does for me. It puts the minimum value of what number? About 43.
At 43.
That's where it should be at, right?
Mm-hmm.
Now, to do the right-hand error bar, instead of, remember for the left-hand error bar, we clicked out here to get there. For the right-hand error bar, you click actually on this box right here. Because it's stopping at the endpoint and it's going to add something to that endpoint. And so again, click on that box, go up here to add chart element. Go to error bars. More error bar options. This time you're doing the right, so that's going to be your plus error bar. Don't know what happened there. I pressed something. Try it again. Chart design, add chart element, error bars, more error bar options. You want to do the plus error bar because you're on your right side this time. And you want to custom this one. Specify the value. Again, for this time you're doing the positive error bar. The positive error bar. Clear that out. The specified value this time, I can't see it because it's behind my chart. It should be Q3. I don't know if that's Q3 or not, though, to be honest. Hold on. Q1, Q2. It should be that value. But it's on the chart area.
Can you move the chart?
I'm gonna have to move it. I couldn't move it like that. I can't move it
Can you
like that.
slide it to the right slightly?
It's not letting me do it. Let me just pick something real quick. Let me pick Q1 again. I gotta get that chart out the way. That's why it's not letting me do it. Hold on. Let's move the whole.
So it won't let you grab it and move it.
Nah,
There.
yeah. So again, pick this one. Pick that one this time. Add chart element. Error bars. More error bar options. You need to pick on this one right here with the option for the bars. Make it a plus bar, custom, specify values. And if I'm dealing with the positive error value, and remember, clear this number out or it'll mess you up. Clear that number out and go to positive error value. And you want to do Q3. I think it's Q3. We'll see. It
Yes.
might actually be the max. I forget which one it was. We'll see in a second though. So press OK. Yeah, that's the right one. All right, no, we want to go to the, yeah, that's right.
Mm-hmm.
Yeah. And that brings me to about what number there? Our max value, which is at where?
96.
And that's pretty close to 96 right there. And this is the actual. And here's how you make your box and whisker. And I'm showing you this right now too, by the way, because on your Excel project, one of the graphs you need to make is going to be a box and whisker. One of the graphs you need to make is a box and whisker. But this is how you make the box and whisker. Now, really and truly, do you have to do that? No. The quicker way to do all of this is just to highlight this stuff right here. Go to test scores. Go to your charts again. Go to your insert charts. You can come here to the insert function, and whatever works. Insert. Right here at your statistical charts, you have box and whisker here. And here is the, here is the box and whisker again, by the way. And it has those values at about, if you label, I can label these values actually. Add data labels. You can actually like see that's at 96, that's at 90, 78.5, 60.75, 43. You can actually see that on there. I think this one will just give you this other one down here will give you just the differences, but we show you both of them in the same view. There. They're the same ones. One is going to be horizontal. The other one is going to be vertical. Do you understand that?
Yes.
But they read the same thing. So here's what I'm telling you. I'm going to know which way you did it by the type of graph you produce. If your graph is vertical, you just went in there and just did it like this with the function. If your graph is horizontal like this, you went in there and actually did the work to do it. I want them done like this. I want you to build the graph. Now, am I going to take off if you don't build the graph? Probably not. Probably not, all right? I'm probably not going to take off if you don't build the graph. But, you know, it's totally up to you. How do you do it? You can also change the scale on these to look better. So, like, if I don't want to see all of this dead white space out here, if I click on this axis part right here and right click, or click on the axis and go over here to no, axis options, and then click on this right here. Say you have a minimum value where you can start at. I can start this graph at like, let's say I want to start the graph at 40 and end it at 100. If I start at 40, it locks, it looks like. They ended at 100. Here's what the graph looks like. So look how much bigger and look how much clearer you can see when it does that. So you can play with the axis. And again, part of your project is formatting graphs and making them show things to me too, by the way. And when you do this, look, you can definitely, do you see how you can see the skew on this now? When you made it bigger like that, you see how you can see it's definitely left skewed? The longer left tail than the right tail?
Yes.
Yes.
We zoomed in, all right? So that is how you make a box and whisker. You can make it there. You can also do the same thing over here with this one, with the vertical. I want to change this. Click on this axis again. Click on the axis. It'll put the box around it. You click on this one right here. Go to options. We're gonna go from 40 to 100 again. And when you do that, again, you see how you can see the skew here? There you can see the skew here.
Yes.
So you still have left skew distribution there. Have any questions?
No. I'm ready.
All right, so I think that we'll stop there for the night. Y'all have any questions? Again, the project, like I said, the project isn't due till October 4th. That does not mean wait till October 3rd to work on the project. I got that. Don't wait till October 3rd to work on the project. Go in there and look at it and see what needs to be done and try to go do those things for it, all right?
Okay.
You got any other questions?
No, sir.
All right, y'all have a good night then.
Thank you.
Bye.